Hello, this is part two of writing equation of the line tangent and normal to the curve. So let's just continue with example 4. So example 4 says write the equation of the line tangent to the curve g of x equals x over x minus 1, where x equals 2. And I got to find the equation of the line tangent. So one thing they have not give us is they don't give us the y value. So you should always check if you do have a you should always check if you have a coordinate, complete coordinate if you don't find it, right? So how would I find my y coordinate? Simply plug in x equals 2 into g of x, right? So go ahead and do that. So that's 2 over 2 minus 1. So that's 2, and then 2 minus 1 is 1. So that's 2. Okay, so that means my y is 2. Okay, the next thing I'm going to do is find slope. So I have to take the derivative. So how do I take the derivative? I'm going to use the quotient rule because this is in a fraction form, so you have to apply the quotient rule. So first I got to figure out my f and my g. So my f is the numerator, which is x, and my g is x minus 1. Then I'm going to find my f prime, which is 1, and then g prime is 1. Okay, so now we're going to do g prime of x. So what is the quotient rule? I should have written it down. It is this f prime of g minus g prime of f all over g squared. Okay, so f prime is 1, g is x minus 1, minus bracket, g prime is 1, f is x all over g squared, which is x minus 1 squared. So 1 times x minus 1 is x minus 1, minus 1 times x is x, all over x minus 1 squared. So if I clean this up, x minus 1, negative x, this would be x minus 1 minus x over x minus 1 squared. So what happens is the x cancels, so you're left with negative 1 over x minus 1 squared. Okay, so my g prime is negative 1 over x minus 1 squared. Okay, so this does not give us the slope, it just gives us a first order. So how do we find slope, which is technically a tangent? You just plug in your coordinate, and because we only have x, I think we're just fine with plugging the x value. Right? Wait, what's my x value? Not 1, it's 2. So it's going to be negative 1, and then it's 2 minus 1 squared. So that's negative 1, and then 2 minus 1 is 1 squared. That's negative 1 over 1 squared is 1. My slope is negative 1. Okay, so that means my slope is negative 1, right? Now all you got to do is put it in point slope form because we have everything. So point slope form is y minus y1 equals to m times x minus x1. So it's y minus y1, which is our y coordinate, which is 2. My slope is negative 1 times x minus x1, which is also 2. So this, you can leave it like this, or you can solve for y, and that would be y equals negative x plus 4. So either way, answers works. If your teacher specifically says point slope form, then we use this. Okay, so that was example 4. Let's move on to example 5. Hold on. What is this? Okay, so in example 5 says, write the equation of the line tangent to the curve h of x equals tan of x, where x equals pi of 4. So the first thing you need to find, or that isn't given, is your y coordinate, right? We need an actual coordinate. So let's plug in pi over 4 into the function h of x. So tan of pi over 4, that is +1, right? Okay, so that means our y value is +1. Then what I'm going to do is find slope by taking h prime of x. So the derivative of tan x is secant square x. And then plug in your x coordinates. So because I need to find slope, h prime of x, which is pi over 4. So what is the secant square of pi over 4? Well, what is just regular secant pi over 4? Because whatever that is, we can just square it. So if you recall, secant could also be expressed as the reciprocal of cosine. So if you know the cosine of pi over 4, you just take the reciprocal of that. So pi over 4. So if you look at your unit circle, pi over 4 is right here. It has an x coordinate of radical 2 over 2 and a y coordinate as radical 2 over 2. So cosine is the x coordinate. If it's a degree within the unit circle, the cosine is the x coordinate and then the sine is the y coordinate, right? So the secant is a reciprocal of cosine. So all you got to do is flip it. So what is the reciprocal of radical 2 over 2? It's just 2 over radical 2. Okay. And then you just square it. So when you square this, this is going to be 4 over radical 2 squared is just 2. And then 4 divided by 2 is 2. So my slope is 2. Okay, so we have everything. We have their slope, and we have our coordinate, which is pi over 4, comma 1. So if we put it in point slope form, it's y minus y1 equals to m x minus x1, right? So it's y minus y1, which is 1. My slope is 2, and then it's x minus x1, which is pi over 4. Okay, so you can leave your answer like this. If you try to solve for y, if you do try to solve for y, you get y equals 2x minus pi over 2. This one. Either answer works. Okay, so that was example 4. Let's move on to example, not example 4, that's example 5. Let's move on to example 6. Okay, so example 6 says write the equation of line tangent to the curve radical x plus radical y equals 3 when given the point 4, 1. Okay, so first I'm going to check if I actually have a coordinate, a whole coordinate, meaning I have an x and y coordinate. I do. I have an x coordinate that's 4 and a y coordinate of 1. Okay, so the next thing I'm going to have to do is find the slope. So how do I find the slope? First, take the derivative. So how am I going to take the derivative of this whole thing? Yes, you said it, implicit differentiation. So you're going to take the derivative implicitly. So in respect to x. So what is the derivative of square root of x in respect to x? It is 1 over 2 radical x. And then you do have the option of putting dx over dx, but not really, because what happens? Dx over dx cancels, right? Now, what about the square root of y? What is the derivative of square root of y in respect to x? It's just 1 over 2 square root of y, and then you do have to put dy dx. Okay, and then on the right side, the derivative of 3 is 0, because the derivative constant is 0. So what we have to do is solve for dy dx. If you want, you could just plug in your coordinate now to make it easier. Let's see if it does make it easier. So we have 1 over 2, and then square root of x. Our x is 4. plus 1 over 2 square root of y, which our y is 1. And then you have this dy dx. So it's 1 over 2. Square root of 4 is 2. Plus 1 over 2 square root of 1 is 1. And then this is going to be 1 over 4 plus 1 over 2 is 2. And then just continue solving for dy dx. So maybe I could subtract, or what can I do? Maybe I could get rid of the fraction. So let's do that. I'm going to multiply all three sides by the LCD. So what is my LCD? We have a 4 here, a 2, and a 1. So my LCD, lowest common denominator is 4. Okay, so I'm going to multiply all three sides by 4. So 4 times 1/4 just cancels, so it becomes 1. Plus 4 times 1/2 dy dx, well, that would be 2 dy dx equals, so 0 times 4 is 0. Okay, so go ahead and solve for dy dx. So I'm going to subtract 1. Solve for dy dx, so I have to get rid of this 2 by dividing both sides by 2. Okay, this actually gives us a coordinate of -1/2. Remember, a constant of -1/2. So you don't have to plug in, we're good. So that means our slope is -1/2. Okay, so do we have everything? Yes, we have the slope, we have the coordinate, which is, our coordinate is 4, 1. So now we could just put it in point slope form. So it's y minus y1. So it's y minus y1, which is 1. My slope is -1/2. X minus x1, which is 4. You can leave it like that. If you try to solve for y, you'll get y equals -1/2 x plus 3. Okay, so either answer works. Okay, so that was example 6. Let's move on to example 7. So example 7 says, write the equation of the line tangent and normal to the curve, okay, of y equals 3x squared minus ln of x, where they give you a coordinate of 1, 3. So this time they're asking tangent and normal. So we're going to have two equations, right? The first step is, if I actually have a coordinate, an x and y coordinate, I do. I have an x coordinate of 1 and a y coordinate of 3, so good. Okay, so let's do the tangent line first. So, because we've been doing tangent this whole time. So how do we find that? So first we got to find the first derivative. So first do y prime. So what's the derivative of 3x squared? It is 6x. What is the derivative of negative ln of x? That is -1 over x. Then I plug in my coordinate. I think I could just get away with plugging my x value because there's no y. So it's 6 times 1 minus 1 over 1. So that's 6 minus 1, which is 5. Okay, so my m1, or tangent to the curve, is 5. Now, what should m2 be, or the curve, the slope should be in order for it to be normal? So normal means perpendicular, right? Normal is perpendicular. And what is the slope of a perpendicular line? It's basically the negative reciprocal of your tangent line, or m1, right? So let me just write that out. What should I'll call it m2. So m2 represents our normal line. So it's just the negative reciprocal of m1. So the negative reciprocal of m1 is -1/5, right? Because the reciprocal of 5 over 1 is 1/5, and then just add a minus. Okay, so now we need that to find, okay, so let's finish with the tangent. So put it in point slope form, so it's going to be y minus y1 equals mx minus x1. So it's y minus y1. So my y1 is 3. My slope is 5. And then it's x minus x1 is 1. Okay, so this is tangent. Now find the equation of normal. So it's basically the same thing, but now we're going to use the slope as negative 1/5. So it's y minus 3, and then my slope is negative 1/5, and then it's x minus 1. So that this equation is going to be normal. Okay, so whenever they say normal, they really mean perpendicular, and what they mean is the negative reciprocal of m1. Okay, so that was example 4. Then we'll move on to example 8. How many examples do we have left? Yeah, we have 2 more. So example 8 says, write the equation of lines tangent and normal to the curve y equals e to the x of sine of x. Y equals e to the x times sine of x plus cosine of x, where x equals pi. So first thing I'm going to check is, do I have an actual coordinate? Meaning, do I have an x and y coordinate? I have the x, but I do not have the y, right? So that's what first thing I'm going to do is find my y by plugging my x value. So that's e, and replace x with pi. So it's sine of pi plus cosine of pi. And that gives us e to the pi. Sine of pi is, so pi is right here, has an x coordinate -1. So sine is 0 plus cosine of pi, which is -1. So that gives us -1 e to the pi. Okay, so that is my y coordinate. So my y coordinate is -1 e to the pi. Okay, now I gotta find my slope. So they want 2 equations, tangent, normal. So let's find my first derivative. So how on earth would I find my first derivative? I would have no choice but to use product rule. I wouldn't FOIL out e to the x, right? I would not FOIL out e to the x and then take the derivative of the individual term, because that means more work, right? So let's apply the product rule. So if you recall, the product rule is f prime of g plus g prime of f. So I believe my f will be e to the x, and then my g is this whole thing, right? So f is e to the x, and g is sine of x plus cosine of x. Okay, so f prime, the derivative of e to the x is e to the x. G prime, the derivative of sine of x is cosine of x. The derivative of cosine of x is a negative sine of x. Okay, so now we just apply the product rule. So f prime is my f prime. My f prime is e to the x times g, which is sine of x plus cosine of x, plus g prime, which is cosine of x minus sine of x times by f, which is e to the x. So what can I do? Is there anything I can simplify or even take out? I think we can. I think we could take out an e, we both have an e to the x, right? Because this whole thing is one term, this whole thing is one term. So I'm going to do that. Let's see if that makes it easier. If I factor out an e to the x, I get sine of x plus cosine of x. And then this is going to be plus cosine of x minus sine of x. Then what I would do is maybe could I, inside the bracket, I think we can simplify. We can cancel the sine of x, right? And now we have one cosine of x and another cosine of x. So that is y prime equals e to the x. And then cosine of x plus cosine of x is 2 cosine of x. Okay, then I gotta find my tangent. So I gotta plug in my, I gotta find slope, right? Or m1. So I gotta plug in my, I think we could just get away with plugging our x value. There's no y. We don't need the y yet. So it's gonna be y prime of my x value, which is pi. So that's e to the pi times 2 cosine of pi. So that's e to the pi. And then it's 2 cosine of pi. What is cosine of pi? It is -1. So 2 times -1 is -2, and then you have e to the pi. So my m1 is -2 e to the pi. Okay, what should my m2 be? Because we need the normal, right? So m2 is just the negative reciprocal of m1. So that would be positive 1/2 e to the pi. Okay, so let's first find my tangent. So we'll apply the point slope form. Okay, so my y1 is, so my coordinate is pi comma negative e to the pi. So my y1 is, what is my y1? My y1 is, oh, right here, like negative e pi. So that would be minus e to the pi. My slope is -2 e to the pi x minus x1, which is pi. So 2 negatives becomes a positive, so that's e to the pi. And then this is -2 e to the pi x minus pi. Okay, so this one is our first equation, and that is the tangent. What is the equation for normal? So this time for normal, we're going to use this slope, 1/2 e to the pi. So it's y plus e to the pi. And then my slope is, no, we're not going to use -2 e pi, we're going to use positive 1/2 e to the pi. And then it's going to be x minus pi. Okay, so this is the second equation, and this is the normal. Okay, so that was example 8. Let's move on to example 9. Number 9 says, write the equation of the tangent line and normal line to the curve. X squared plus y squared equals 25 at the point -3, 4. So first step is check if I actually have an xy coordinate. Yes, I have a -3 as my x and a +4 as my y, so good. So the next step is find the derivative, and we're going to have to take it, we're going to have to implicitly differentiate in respect to x. So start with the first term, x squared. What is the derivative of x squared in respect to x? Well, the derivative of x squared is 2x. You do have the option of putting dx over dx, but not really, because that just becomes 1. Okay, the next term is y squared. So what is the derivative of y squared in respect to x? So it would be 2y and then dy dx. And then on the right side, the derivative of 25, our constant is 0. Okay, and then I gotta find dy dx, so I'm gonna plug in my coordinate. So it's 2 times x, which is -3, plus 2 times y, which is 4, times dy dx. This is 0. So 2 times -3 is -6, plus 2 times 4 is 8, dy dx. This is 0. Solve for dy dx, so I'm gonna add 6, add 6. 0 plus 6 is 6, and then divide this by 8. So I get dy dx. The derivative of 6, 8 can be reduced by 2, so that would be 3 over 4. Okay, so this is like my M1. What should M2 be? Because we want normal. The negative reciprocal of M1, so that would be -4/3, right? Okay, so now let's find the equation for tangent line. So it's going to be y minus y1. So wait, my coordinate was -3, 4. So my y1 is 4. My m1, or dy dx, is 3/4. And then it's x minus x1, which is -3. So 2 negatives becomes a positive, so really it's just +3. Okay, so this would be this one. So this would be norm tangent. And then let's do the normal. So it's going to be basically the same thing. It's just our M2 is -4/3. And this would be your equation for normal. Okay, so that wraps it up for writing the equation in both tangent and normal. Okay, I will stop here.